stack, we will store the index of the parentheses, and we will start with the -1, because in this case we can calculate the length and for the leftmost parentheses. And also every time we see a left parenthesis, we will just add to it to the stack. When we see a right, we will first pop. So pop and then calculate the distance, because when we pop, we can calculate for example here, if we pop, then we have the index 2 minus the 0, and we can get the correct length. And in another case, if we don't have the left parenthesis, if we pop, then the stack is empty because we popped the -1 here. So we will just add the empty, just the right parenthesis index to it. And for example, here is 2. And the next time we meet a for example, right parenthesis, will pop again. So and that append, so it's just 3 here. So every time if this is the because this is the same function as the -1 we initialized. So next time we see a left parenthesis, so we can become the 3 and 4. So now we can know the length because of the 3. So you see here would be the 5 minus the 3 equals 2. So the length is 2 here. This is for just the indexing. So it can help us to calculate the length. So let's continue to implement this algorithm. SS, and if the SI is the left parenthesis, the open one, we just add it to the stack and the index. Else we first pop. If the stack still have value, it means we are the parenthesis valid, so we can update our max length. We will initialize this as 0. Max length is max of the max length and the I minus stack, the last value in the stack. Else, we just append this index. So yeah, no, keep the stack not empty for calculating length. Okay, at the end we just the max length, return max length. And this should be correct now. Okay. Yeah, thank you. And this is the first solution. And we have another one is to use dynamic programming to do this. So that should be a kind of more induction for the induction rule, transition function. So let's say the DPI means the just a longest valid parenthesis, parenthesis, and let's see if we if we meet a right parenthesis, it means we can now calculate the valid parenthesis longest, because we might have a match. So let's first take a look at the example. So if we have a, let's say it's here, we have it's 1, 2, 3, 4, 5, 6. So so here we have ix6, and we already know the dpi minus 1. So we will make like a symmetric place to see this is 4, this is 4. So we will jump back to the 1 here to see if this one is like the left like open parenthesis or not. If it is open parenthesis, then we know we have a match, so we can add 2 to our the dpi is close to the dpi minus 1 plus also we need to plus the number before it, and because here is 1 and here might be another like value parenthesis, we don't know, so we also need this value, so this would be the dpi minus dpi minus 1 and minus 2 is this one, so and plus 2. So this is our transition function, how we update these values. So let's see, and because we have like need to see the negative one here actually, so we may need to set the dp matrix a little longer, so it should be the 0 s length s plus 1. So this might make the dp index kind of different. So this is 1 now, 2, 3, 4, 5, 6, 7. For I in range 1 to the length of s plus 1. So now if si minus 1 it is the right parenthesis, means we need to calculate dp0 is 0, dp1 is also 0. In the right parenthesis, we need to calculate dpi equals to dpi minus 1 plus dp. And we need to check n I minus dp I minus 1 minus 1. So here would be the 1 minus 0 minus 1. It's just a 0. Actually, we need to see the negative one, so should be minus 2. It's greater or equal to 0. And yes, should be equal to the left parenthesis. So we need to update. Then we need to update. the dp value here. Okay. Let's take an example. So for example, we have the I7 here. So I7 is 6. Yeah, 6, and 6 is 4. So 7 minus 4, 3. 3 minus 2 is 1. 1 is greater or equal than 0, and this 1 is left parenthesis, so we need to update. So it should be the, let's see the number, 7 is dp6 plus dp6 minus 4 minus 2 plus 2 equals to dp6 is 4, dp1 is 0. Yeah, it's plus 2 equals 6, and it's correct. And that's it. We just return the max value of the dp. Let's see if this works. Take more examples. I just submit. Okay, and let's take some corner case here. Length of s smaller or equal to 1. Let's return 0. Okay, it's passed. Okay, this is two good solution we can think of. And there's also another solution, but it's kind of difficult to prove for me. And just go through left and go through the string from the left to the right, and then from right to left, and calculate something. You can check it in the solution. So it's it just saves the capacity for the stack and the dp. So without any extra space to do this. Okay, thank you.